For Phase 3, we were challenged to create a dry stack arch, an arch without using mortar. And this posed a particular problem for us since we were replicating the Guastavino arches and domes in the City Hall station. Mortar is a very critical component of this method of construction, and as Guastavino outlines in his essay on the theory and history of cohesive construction, without using mortar, essentially one layer of voussoirs creates a system in which gravity and friction are the primary forces that support an arch, whereas if one were to add mortar and another layer of bricks and so on, a new system emerges, that of cohesive construction. So, in order to face this new challenge, we decided to take a new direction, and that was creating lightweight concrete voussoirs to challenge ourselves in this dry stack competition. To create a lightweight but strong concrete, fiber was used as well as small styrofoam beads. Meanwhile, the principal ingredient in our concrete was Portland cement.
And then wait. Let's see how.
Once measured by weight, these ingredients were carefully organized and prepared for mixing. Before these ingredients were mixed, however, 3D printed molds were created for each of our voussoirs. With the molds ready and materials carefully measured out, the components were ready to be mixed. Most importantly, water was then added to the mixture.
Don't add the whole water. Just we have to get to consistency. I don't know how much water we need. So you keep adding it, and we check it, and then you add more. More water?
Yeah.
So the first layer is not too much. Tap it. Nice. It might be a little bit less than what we want.
Well, I'm making a little bit more than what I need, so 3 liter, it's more than what we need, so.
After curing for 24 hours, voussoirs were demolded using a soldering iron against the polymer 3D printed molds.
There's a great ball from Untitled. Taking count outside, does it correctly down across the keeper. He just puts it back in the play, brings it back over the line for the
Once the demolding process was complete, voussoirs were placed into a bucket of water to further strengthen them. A total of 31 bricks needed to be created for this project, so this process was repeated multiple times. After all the bricks were manufactured, a scaffold was created out of high-density foam. For construction, testing equipment as well as the voussoirs necessary to construct our arch were brought up to the roof of the Spitzer School of Architecture. The arch was then constructed horizontally in a semicircle, to compare with the foam created for its construction.
I don't mind if you do it.
Yeah, for the
At the center of our construction was our testing equipment, which passed directly through the arch.
None of them are this one's a bit.
add another camera this way. This is also nice.
Can you use it?
A little bit more, we're done. Abram, you should move. Aha, yes. Here we go. Good job.
Incredible. All in all, a semicircular arch was constructed containing 31 voussoirs with an 18.5-inch intratus and a 23-inch extratus, as well as height. Each voussoir weighs 763 grams, giving a total weight of 23.7 kilograms to the arch. Thank you so much for watching. We'll see you in the next video when we test the arch.